we're gonna do section 2, maybe section 3 today. First off, in order to graph polynomials, we have to understand a couple of things about polynomials in the first place. Whenever you set up polynomials, we put them in decreasing order of the highest exponent. The highest exponent is called the degree of the polynomial. The part of the polynomial that has the highest exponent is called the leading coefficient. The last term that doesn't have an x, it's the constant. So if it doesn't have any x's, it's just a number by itself, that's the constant. The constant is always, always, always your y-intercept. That's where the graph is always going to cross through the y-axis, through that constant. So the leading term, in this case, is that's the leading term. I'm sorry, that's the leading term. The whole thing is a leading term. The leading coefficient is the number in front. So for example, if we have that polynomial, our leading term is 3x to the 5 because it has the biggest exponent. The leading coefficient is 3. It's the number in front of the x. The y-intercept is 7. So it intercepts at the point 0, 7. All right, so, and those two parts are the most important, the leading term and the constant term. Leading term. The degree tells us the shape of the curve. By shape, it tells me where the ends of the graph point. We call that end behavior. If n is even, both ends point the same direction. They are both either going up or they're both going down. If it's even, if the degree is even. If n is odd, the ends point opposite directions. Like that, or like that. You notice I'm leaving a blank in the middle here because that's another thing that the degree tells us. But we're now for the end behavior. If the degree is even, we know both ends point the same direction, either up or down. If it's odd, one end points down, one end points up. The direction depends on A. So let's look at, I'll make a little chart here for y'all. And the first column, n is even. The second is n is odd. The first row, A is positive and A is negative. If A is positive and it's even, they both point up. If A is negative, they both point down. If A is positive and n is odd, it's an increasing function, meaning the right side goes up, the left side goes down. If it's negative, it flips. So we can tell a lot just by looking at the polynomial itself. So if I give you any polynomial, you can look at the first leading term and see what the basic shape of the graph is going to be. Then you can look at the constant term and see where it crosses the y-axis. If n is even, okay, n also tells us the maximum number of X-intercepts. Remember, X-intercepts are the same thing as solutions. Remember, I said maximum number. If n is even, you can have anywhere from 0 to n intercepts. Let's see what that means. Let's say our equation was if the leading coefficient, the degree is even. This up here doesn't mean anything to us just yet. Remember, since it's even and the leading coefficient is positive, both ends point up. We know the graph is going to look like that. So it tells us we're going to have 4 intercepts. 1, 2, 3, 4. We can have 3 X-intercepts. One touch at one point and cross at 2. It can have 2 X-intercepts. It can have 1 X-intercept, or it can have none. Because the whole graph could be shifted up above the x-axis. Remember, it works the same way if the leading coefficient is negative, it just points down. If n is odd, we can have anywhere from 1 to n. Evens, they don't have to touch the x-axis. Odds have to touch at least once. So this is a cube. So it tells us we have 3 possible solutions. And it's positive, so it's increasing. 1, 2, 3. We can have 2 solutions. You just touch right there. Or it can have 1. But since it points opposite directions, we know we have to have at least 1 solution. The degree also tells us. So the degree is 4. N minus 1 number of vertices. So the degree minus 1 tells us the maximum number of vertices we can have. The vertices are the high and low points. Since if it's 4, we know we can have at most 3. Here's 1, here's 2. The vertices are the high and low points of a curve. 1, 2, 3. And the cubic function, 1, 2. So it's 3 minus 1 equals 2 vertices. 1, 2, 1, 2. So that's all that stuff comes from just looking at the first and last terms. Again, the y-intercept, we get that from the constant term, whatever the constant term is. So we haven't even done any real math. We just looked at the equation and we can tell that much already. All right. To graph, let's try with quadratic equations first. To graph a quadratic equation, remember a quadratic equation looks like this. We need X-intercepts. Direction of the curve. The shape of the curve. The y-intercept. And the vertices. So let's look at this. X squared plus 7x plus 10. Just by looking at this equation, we know the degree is 2, so it's even. That means both ends point the same direction. Since the leading coefficient is 1, it's greater than 0, we know that our ends of our graph will point up. We know the y-intercept is 10. And we're going to have at most two x-intercepts. Let's find them. The way we find them is factor this. To find the x-intercepts, well, we know the direction. It's pointing up because a is equal to 1, which is greater than 0. The shape is a parabola because n equals 2. The y-intercept is 10 because that's the constant. The x-intercepts the way you find the x-intercepts is you have to set y equal to 0 and solve. So let's try factoring first. Leading term is x squared. The second term is a plus. That means they're both the same. They're both going to be the first. They're both going to be plus. What times what is 10? When you add them, you get 7. 5 and 2. So once we factor them, we take both of those equations and set them equal to 0. Because that's what the equation equals to. So the answers are going to be -5 and -2. So in our picture, we have at -5 and -2, and it goes through 10. Now, the only thing we need to find now is a vertex. The equation for the vertex comes from this equation, the quadratic formula. The quadratic formula tells us our solutions, our x-intercepts. That's what this actually finds for us. But the x part of the vertex, if this is gone, that is the x component of the vertex. Negative b over 2a. To find the y value of the vertex, plug the x value from above into the original equation. So the vertex is a point. It has an x and a y component. In my equation, x squared plus 7x plus 10, we know we have a is 1. That's the leading of x squared. B is 7, and c is 10. So the x component is negative b over 2a. So it's negative 7 over 2 times 1, negative 7 over 2. That's the x component of the vertex. Negative 7 over 2. Now to find the y value, take this x value and plug it in place of x in the original equation. Negative 7 over 2 squared. 7 times negative 7 over 2 plus 10. So negative 7 squared is 49. 2 squared is 4. 7 times negative 7 is negative 49. 1 times 2 is 2. And this is 10 times 1. Now to add fractions, we have to add or subtract. We have to have a common denominator. So since the smallest denominator all of them fit into is 4, leave that one alone. This one needs a 2, so multiply top and bottom by 2. 2 times 49 is 98. 2 times 2 is 4. And this one by 4. So it's 40 over 4. 49 plus 40 is 89, minus 98 is minus 9 over 4. That's the y value of the vertex. So the vertex is at negative 7 over 2, negative 9 over 4. Which is negative 3.5 and negative 2.25. Which is approximately negative 3.5, negative 2.25. Let's do another one. Let's find the same 5 articles on this next equation. Let me see. 2x squared minus 2x minus 12. So we have to find these parts. X-intercept, Y-intercept, vertex, direction, shape. All right, so let's look at this. We know the y-intercept is negative 12. Since A is 2 and it's positive, it opens up. The degree is 2. So it's a parabola. We'll have two intercepts. So the direction is up. The shape is like that. The y-intercept is negative 12. So now we got to try to factor it out. Since it doesn't start with a 1, we'll just put 2x and 2x. The second sign's a minus, so that means one of them has to be positive, one of them has to be negative. The bigger number gets the negative. What times the first number times the last number? So we have 2 times, let's leave it as 12, is 24. So what times what equals 24? Since the second sign's a minus, when you subtract them, it equals 2, the middle term. So what times what equals 24 when you multiply those? And it has to equal 2 when you subtract them. 6 times 4 is 24. 6 minus 4 is 2. So 6 and 4 are the numbers. And since the first sign's a negative, the bigger number gets the negative. So 6 and 4. Next step, factor these out. Let's see, what do they both have in common? They both have a 2 in common. And they both have a 2 in common there. So we can get rid of what we factored out. So we have x plus 2 equals 0, x minus 3 equals 0. So x equals -2 and x equals 3. Those are my x-intercepts. So we have these 3 points. And we know it opens up. So from this right point, it goes up. And from this left point, it goes up. Because remember, it's a parabola, so it's symmetric. 1, 2, down 12. 1, 2, down 12. So it has to be another point there. So the graph has to look something like this. We just have to find that y-intercept. I mean the vertex. We have to look for the vertex. Remember, the vertex is -b over 2a. And once you find that, you plug that back in the equation to find the y value. Our equation was this. So a equals 2, b equals -2, and c equals -12. The x value is -b over 2a. Negative. B is -2 over 2 times 2. Negative and negative is a positive. 2 cancels, so it's 1/2. Now we take that value of x. Anywhere we see an x in our equation, we plug 1/2 in. And then simplify. 1/2 squared. So square both the top and bottom. 1 squared is 1. 2 squared is 4. The 2's cancel. The 2 and the 4 cancel. So we have 1/2 minus 1 minus 12. 1/2 minus 13 makes it -12.5. So that's my vertex. So far, so good. Now, the x value has another name because parabolas are symmetric. Whatever's on this side maps on that side. So the x value of the vertex is also called the axis of symmetry. All right, let's look at a little bit bigger equation. Those are quadratics. Let's look at something even bigger. graph this one. Actually, I should say sketch because we can't do the actual graph just yet. The X-intercept, the Y-intercept, the direction, shape, the vertices. Again, we can't do the vertices just yet because this one's going to be a little bit more tricky. So I'm picked this equation first off because that's what chapter 4 is about, is how to solve higher order polynomials. How many x-intercepts are we supposed to get in this equation? At most 3. We have at most 3 solutions. The y-intercept is at the constant -4. The direction, is it going up or down? Well, since it's cubic, since it has an odd exponent, not odd degree, both ends point this different directions. Since the leading term is positive, the left side goes down, the right side goes up. And the shape looks like that. And we're going to have 2 vertices at most. So the first method I'm going to show you all is a method called grouping. You have 4 terms. In grouping, you put a parenthesis around the first 2 terms, and a pair of parentheses around the second 2 terms. Since the middle sign has a negative, incorporate that in the parentheses. So that was the first step. Second step, what can you factor out of both of them? What can you factor out of the first one? They both have at least 2 x's, don't they? So I can take out x squared. So if I take out 2 x's, I have a 2x in front. And since that one's gone, I have a 1. Remember, whenever you factor something out, to figure out what remains, divide those by what you factored out. X cubed divided by x squared. There's 2 x's are gone, so I only have 1 left. Both of these are gone, so it's a 1. And the second parenthesis, they both have a negative, so we factor out a negative. And they both have a 4. So I took out a 4. So 8 divided by 4 is 2x. Since I took out that negative there, I changed the sign, so this one's a plus. If I factor out a 4, I got a 1. So whenever I factor out the negatives, it became positives now. Now look at these two equations. We only have two terms. What do they both have in common? They both have a 2x plus 1 in common. So if I remove the 2x plus 1 from both of those, I factored it out. What I'm left with, the coefficients go in their own parentheses. All right. Now, looking at the second one, we notice that it satisfies that condition. It's the difference of two squares, x squared minus 2 squared. And that one becomes a plus b, a minus b. So it's the same terms. Whatever's under the squares, x plus 2, x minus 2. It's the difference of two squares. Whatever's under the square goes inside the parentheses. And since we have 3 parentheses, that means we're going to have 3 solutions, which is how many we're supposed to have. That's what the degree told us. We have 3 solutions. Set them all equal to 0. And solve. So subtract 1, divide by 2, so it's negative 1/2. Negative 2, positive 2. Those are my x-intercepts.
I have a question.
Yes. Yes. Go ahead.
I'm confused how you got from factoring 2x plus 1.
Mm-hmm.
I thought they both canceled out. So why is
No,
it
no,
still
no.
there?
The reason they canceled out is because I removed them. I looked for whatever I had in common. Like what we did here. In the first part, when I had 2x cubed plus x squared. And what they had both in common, they had x squared. So in like 2x cubed is actually x times x squared, right?
Hmm.
So since I took out an x squared, I removed it from inside there. It's now in front. So all I have left is 2x plus 1. And the same thing happens with our bigger equation.
Okay.
So since they both have a 2x plus 1 in common, I factor that out. Now, whatever's left, if I divide both of those by 2x plus 1, that cancels and that cancels. All I have left is x squared minus 4. Is what you have left always will be the coefficients.
Okay.
That's a very good question because a lot of people get mixed up on that point. So if I had how would I factor that one out? What do they have in common?
X and 2.
X plus 2, right? They have x plus 2 in parentheses. So since they have that in common, I remove it. I put it out by itself. And whatever's left goes inside the other parenthesis.
Oh, okay, you don't get rid of it. You just,
Factor it out. Yeah, I'd pretty
Right,
much,
okay.
I'd just take outside, and I should have a parenthesis around these. I got rid of them. I put them out in front. That,
I
yeah,
understand.
I should put the parentheses around this big equation, because it is an equation. I should put it in parentheses. Good questions. Hmm? In this one? Right? Well, it really doesn't cancel out. It shifts. I just pick it up and move it somewhere else. Because remember, I started off with this. And then when I factored out that what's in common, I have that. I factor out what's in common, I have x squared plus 5. So I went from here to here. I just I moved those out in front. Because now, if I took this equation here and multiplied inside there, I get the same thing. You have to be able to check your steps. Yeah, I see, and that confuses most people when we do the grouping method, that one part right there. All right, so in our graph, what do we have so far? We know our x-intercepts are at -1/2. -2 and +2. We know that our y-intercept is -4. Since a is positive, the leading coefficient is positive and it's odd, that means on the right-hand side, it goes up. On the left-hand side, it goes down. So the graph will look something like this. Okay. Remember up here that we figured out all this stuff here. We have the x-intercepts, there's 3 of them, we found those, the y-intercept. The direction, the right side goes up, the left side goes down. Now, it goes up from the very last points, from the outer end points. It goes up from the last one, it goes down from the far left one. And since we know we had another intercept here and a y-intercept, since it goes this way, it has to cross up there and come back down. So we know that's the shape of the equation. It's just that for right now, we don't know what the vertices are. Okay, let me see here. I'm going to give you a bigger one. I'm going to factor it for you, and you sketch the graph. Okay, this is what I give you so far. Later on next week, you're going to know how to factor it yourself. But after a lot of work and effort, you come up with this factor. So go ahead and graph it. How many answers are we supposed to have? Yeah, because the degree is 4, we're supposed to have 4 answers. How many do we have? Yeah, here's 1 here, there's 1 here, and there's 2 there. So yeah, we're going to have 4 answers here. It's very possible. I mean, if I just gave you the equation y equals x squared, we're supposed to have 2 answers. The vertex of this is at y equals 0. If you have 2 of the same answers, it's like that. And that's what I'm going to show you here in a second about these exponents, what they mean. They tell us a lot, actually. What I should have done, I should have gone ahead and given it to you this way. Because next week, when we do these by ourselves, you'll come up with the second line. And then from there, you can, since x minus 2 happens twice, you can put that square there. So what can you tell me about the equation right now? By looking at the equation, what can you tell me? It has 4 intercepts or 4 solutions. The y-intercept is -16, very good. What's the shape? The degree. The degree is 4. It's the highest exponent. And a is equal to, yeah, a is equal to 1. It's whatever's in front of the highest exponent, and that's greater than 0. So we know that since it's an even degree, we know that both ends have to go up. And since that x minus 2 happens twice, we only have 3 solutions here. So x equals -1, x equals 2, and x equals 4. We know we have a y-intercept at -16. We have an x-intercept at 1, an x-intercept at 2, or -1 at 2, and at 4. At the end points, at -1 and 4, so those are the outer points, we know our graph will be going up. So we know this side's going up here, and we know this side's going up here. What happens in the middle? We know we have a y-intercept there, so it has to go from here all the way, at least through that. Or it can go down and back up. But all we know is it has to go back up. And what happens at +2? Because remember, this one's going down. It can't go up anymore. Since this one has to cut through there, it has to bounce off there. So there's our graph. A rough sketch of it, I should say, not the actual graph. And I knew this was going to happen because of that. Well, what are the powers here? Yeah, 1. Those numbers, the exponents of the answers, if you get an answer to say x minus a is n1, n minus b, or x minus b, n2, x minus c, or x plus c, where a, b, and c, those are your x-intercepts. N1, N2, N3 are called the multiplicities. It tells us the number of times that answer occurs. That's a multiplicity. But it tells us more. For a multiplicity, if n is even, the graph bounces off the x-axis at x equals a, at the solution. If the multiplicity is odd, the graph crosses the x-axis at that solution. So let me give you so this is what it says. If the multiplicity is even at that solution, at the a value, it's going to bounce. It's going to come back down on the same side of the x-axis. If it's an odd exponent multiplicity, then it's going to cross. Here's an example. Roughly sketch that graph. First, what's our degree? Let's look at our last example. The degree of this one is 4. But let's look at it from this part. How do we get 4 from this? If we add the exponents, multiplicities, it gives us the degree. So in this example, we have 3 plus 5 is 8, plus 2 is 10, plus 6 is 16, plus 4 is 20. So that's the degree. So what does that tell us? If the degree is even, what does that tell us? No, the degree tells us whether both ends point up or down or opposite. Since all the x's are positive, or leading terms positive, and the degree is even, so both ends point up. So let's find the x-intercepts. This one is going to be 2, -1, +4, 0, and +1. So I just took, remember, it's always the opposite of what's assigned inside there. So it's negative x minus 2, it's +2. X plus 1 is -1. We know the end behavior from the both endpoints, they have to go up. Now, what happens at -1? Does it bounce or go through it? This one here.
Goes
it's
through?
odd. It goes through. Since it's odd, it goes through it. What happens at 0? So we got this one done. Happens at 0. What happens with this one? It bounces. At +1, this one. The multiplicity is even. Remember, even you bounce, odd you cross. So that one bounces also. At +2, it's odd, so you cross it. And at 4, it's even, so you bounce. So that's how these multiplicities work. Makes a little bit more sense? So, I mean, the hardest part now is going to be factoring it out. I mean, this one equation here, since the degree is 20, your equation would start off at y equals x to the 20th power. And that's not going to matter much to us. We're going to learn how to do it on Monday and Tuesday and Wednesday. We'll stop there for right now. Yeah, and I'm sorry about last week when we had that big storm. All the weather said that it's supposed to come around 1 o'clock, between 12 and 1. It's supposed to hit Dallas Monday. And what happened? Nothing until nighttime. But welcome to Texas. All right, everybody. That's it for today.